Let's solve this problem using our knowledge on quadratic relations. Distance between the legs of Golden Gate Bridge in San Francisco is 300 meters and the arc is parabolic in shape. The maximum height of the arch is 65 meters. Sketch the bridge and label the key points. Find an equation to model the shape of the bridge. Okay, let's sketch the bridge. So the information that's given to us is that the legs are 300 meters apart. So let's draw that. And it has a parabolic shape. So that would be my y, and this is my x-axis. And it has a parabolic shape, so let's draw a parabola. So it starts at 0, and the distance is 300, so it's going to be in meters. And that's 300. And what else is given? The arch is 65 meters. The maximum height is 65 meters. So this must be 65. So it's at 65. I'm just going to label that here as well. 65 meters, and this is 300 meters. So these are the information that's given to us. So we have the height. We have the distance between the two legs. Let's see what else we need. Okay, so from what's given in the question, we know that the vertex is at 65. The y-coordinate of the vertex is 65. To find the x-coordinate, we know if we have the two x-intercepts, these are the points at which the graph intersects the x-axis, 0 and 300. So if you know the two x-intercepts, we know how to find the x-intercept of the vertex. So let's do vertex. So the x-intercepts are, from what's given in the question, 0 and 300. So what I'm going to do is to find the vertex, actually the x-coordinate of the vertex, I find the average of that. I add them up and then divide by 2, which is going to be 150. So that would be the x-coordinate of the vertex. Now, what I have to do is I have to write an equation to model the shape of the bridge. So this is a quadratic equation. So let me write a general equation with variables. So it's going to have a variable here. And since I know the x-intercepts, I'm just going to write that in here. X minus 300. So 0 and 300 are my x-intercepts. Now, to find what I need to know what A is. So what I'm going to do is, since I know the vertex, since I've already found the vertex, 150, 65, what I'm going to do is let's write the equation again. A, I'm just going to write x minus 300. And I'm going to label this equation 1. Now I'm going to substitute the vertex, which is 150, 65 into 1. So when I do that, let's see what happens. So y for me is 65, and A is what I'm trying to find. X is 150. And x is 150 again, minus 300. Let's see what that comes out to. It's A times 150 minus 150. So that's going to be A times negative 22500. So 22,500 would be the answer, negative. And so that's going to be 22500A. That is 65. Now I have to solve for A. I have to move the A to the other side. Let's do that. So it's negative 22500A. It becomes positive. And then when the 65 moves to the other side, it becomes negative 65. Now I have to isolate A. Let's divide both sides by 22,500. Let's do that. Both sides, and A is going to be equal to negative 13 over 4,500. Now that I know A, I can write the equation that models the equation of the bridge. So therefore, the equation that models the shape of the bridge is y equals negative 13 over 4,500 times x minus 300.